Okay. So the purpose of this training is to go over the Opti 6100 provisioning and how it, gets configured on the Fusion network. There are several Opti 6100s, actually 4 to be exact, in Little Fray. They're basically, in the basic sense, all the Opti 6100 is a SONET to Ethernet conversion device. It takes in an OC48 from Verizon and it converts it to Ethernet to the Fusion network. So, we can land it on our network via IP, wherever, Smart Edge, the Burr, or whatever Burr router it may drop down to. That's the most basic sense in what it does. There are a couple documentations online that go over the actual provisioning process. But I guess I'll go over, with the specific example, being that this is on one of the new hubs, actually the brand new hub that we turned up. This kind of looks a little, the way this looks is kind of, it's kind of all over the place in Little Fray because, some uplink to the Smart Edge, some uplink to the Manhattan Burr router, and it just depends on the hub it comes back to. In the future, it will all be aggregated to one IP device ultimately, but right now, since we've ran out of capacity on that Smart Edge in Little Fray, we're left with chunking it up to the Manhattan Burr router for now, off that 10 gig port. So let's, I'll show you the switch that they currently, these ones currently come back to. So if you look at the interface description on this, you'll see all the mid-speed ports that they uplink to, off of the Opti 6100. So basically the high-speed side is the OC48. You have the working and protect on them. And then you have the mid-speed side, which is, the Ethernet ports that, spit out to either the Smart Edge or some switch or what have you. So for and you'll see in the interface description, you'll see what actual, Opti it comes out, it uplinks to. So these silly codes here, like DPSIL, JD, HVX, DPHVY, those are the silly codes that you'll obtain a CFA from the IC that comes from Verizon. That denotes the OC48. So the DPHVY OC48, that is reserved for one specific ADTRAN. The DPHVY doesn't exist across multiple ADTRAN Optis. It's on one ADTRAN. So that's why, I classify it by the actual silly code to make it easier. And then, I make it even easier by putting the actual IP of the device, the ADTRAN, in the port description. So each mid-speed port on the actual ADTRAN is a 2-port gig card. So there's port 1 and port 2, and then you got the second mid-speed card, which is also port 1 and port 2. If you look down here you'll see some other ones. This switch here that I'm in now is a stacked pair of 3750s in Little Fray. It's 48 ports, copper native, with 10 gig uplinks. So if you look at here is the 10 gig uplink that basically goes to New York City. It's the Manhattan Burr router where you have been building all your sub interfaces. So this is not something you need to really be in and do because I provisioned this ahead of time. So if you look at one of these port configuration, show running gig 101. So I don't know if who remembers, last week when we went over pseudo wires, with the ping-tone network, I had to do a .1Q tunnel to do a Q and Q. Well, I'm doing the same thing here. So basically the outer tag, it identifies what ADTRAN port it goes to, and then the inner tag is what gets passed through the Opti, whatever inner tag you guys choose for the, for the CPE, it doesn't matter. Jason and I had talked about kind of doing, going down the road and using a standard convention, but in the past, the inner tags are what goes to the Opti. I've just chosen, whatever kind of makes sense to me. So you don't, again, this is pre-configured ahead of time. When I light up the actual OC48 hub, I actually provision the .1Q tunnel port, and that's in that email. Get my Outlook open. go to my sent email. There we go. Subject. Look for the carrier hub. So this right here is the description. What I have outlined in this email is basically what I just described to you guys. So the mid-speed ports, connect to these, ports on the ag switch, and then the actual adder tag, it identifies what mid-speed port it drops down to on the actual OC40, on that actual ad tray on Opti 6100. So again, that's due to get redone at some point, and it'll all be uniform. But for now, this is unfortunate, but that's the way it has to be. So we can actually get the customers in service. So I guess let's go to this example that Dal has, that he has to turn up a customer, and let's go into the Opti. Since I think most of you guys are aware of provisioning a sub interface on a Cisco router, so that's pretty self-explanatory. What's his email? And I will try and get a diagram of how all this connects to Notify right now. It's a big undertaking because there's a lot of moving parts. Dale from last night.
So just real quick, when we're provisioning on those, we build the sub interface Q and Q on that aggregate switch.
No, the Q and Q, your Q and Q sub interface lies on the Manhattanburg router, the BER1.LGA1.
Okay.
And I'll get into that after once we go through the Opti, because that's like a 5-minute thing, if that, to go through that. But right. I went to the switch so you guys could see how it actually connects to the switch on Notify. You guys don't have to touch it. That's all done ahead of time. It's Q and Q. All the VLANs, all the inner VLANs just pass through it because it's Q and Q. So let's get into that Opti, which is 172.16.3.140. I even forgot the IP now. And, it's on Orion, but, I also have it on the, I label the port on the actual switch here at 147. These are all Telnet. Most of them should have TACX functioning by now. At AdTran Optis and MX 2800, 2020s get kind of funky with the TACX deal, unfortunately. There it goes. So when you first log in, you see the high-speed controllers. These are the OC48. So you have one's working, one's protect. If you ever want to know which one is active, you would go to any of them. It doesn't matter. And then you would go to 3 status, and then you could go to the equipment. If you see it in service active, that means it's the primary one, or the working path. Versus like if I go to the second one, rather the third one, go to status, equipment, you see it's in service standby. So in service standby, this means that this card, this OC48 is the protect path right now. So the mid-speed modules is, where you do all your VLAN provisioning and your flow provisioning and all that kind of good stuff. But first, you actually have to map the actual circuits. So this CFA indicates slots 1, 2, and 3 on this OC48 on 100 meg, and it's a 100 meg commit. So the reason why we do 3 STSs is because if you only did 2 STSs, yes, that's true. It's 50 meg per STS that would give you 100 meg. But in this type of SONET environment, you lose about 7 to 8 meg of overhead through the SONET payload. So you're down, the customer's actual throughput, they would only see 92 meg, and we have had customers complain about that. Losing 8 meg on a 100 meg circuit, I can understand why a customer would complain. So, we've over-provisioned, so now we can get when we actually lock the committed information rate, we can get it closer to the 100 meg commit that we sold the customer. So, we're losing almost 50 meg of overhead, but, the customer's getting what they paid for. It's different in a regular Ethernet or like a regular Metro Ethernet circuit, a 100 meg Metro Ethernet circuit, say from Verizon or from XO. It's a different type of product. It's not a SONET product where you have the concept of the overhead. So to start off, you would go to either 2 or 3. and then you would want to go to the provisioning, and then we go to 8 mapping, and then you got to make sure you map your STSs. So, hey, Dale, I have a question for you. Did the provisioner IC indicate if this was an STS1 or STS3C?
No, they didn't actually.
Okay, so that's something we should find out, actually, since, this call's canceled today. You have time to figure that out now.
Yeah.
The reason why I asked that is because an STS3C is basically 3 concatenated STS1s together. Being that you see it's slot 1, 2, and 3, that's 3 consecutive, so they could have provisioned this as an STS3C. And if that's the case, we also have to provision it as an STS3C. We have to match on both sides. Like Verizon can't be an STS3C and we're 3 individual STS1s.
So that's probably, Kurt, that's probably why we got the alarm. With the first one was when we built it last night, we got the alarms on 2 and 3. 1 was okay when we looked at the alarms or status. It was 2 and 3 were OS dash FLT. So that may be what happened.
Well, we can, unmap it and take a look. So if we go to 3, STS1 provisioning, it doesn't matter. You can go to 1 for both high speed. So in the left pane is basically where you would select your high speed. You always want to do both HS1 and HS2 mappings to guarantee that the working and protect are always going to be provisioned together. So, because if you only did, say, you did 2 just west. See, now this is high speed 1. This is just the west side, and it could be a potential where if you provision over the west side, then it's not going to replicate over to the east side or the protect path. So you always want number 1, both HS1 and HS2 mappings. So on the, let me move this out of the way here. It's over. There we go. So you always select the high speed here, and these are all your STSs. So as you know, OC48 is 48 STS1s, comprised of 48 STS1s. So if you look here, it has some mappings already existing. So it tells you, so right now it's mapped to MS1, VCG1. And you can see here, here's 3 individual STSs mapped here. So this is how you would map an STS1 or 3 STS1s, or you could put 2 in there, what have you. So let's remove them, and let's do an STS3C. Destination is protected. I got to figure out how to, okay, so you want to delete the map. It's going to say loss of service. Well, yes, it's not in service yet. So let's remove 3. So I removed all 3 mappings. You can do them individually, or you could do them consecutive. So let's actually provision it as an STS3C and see what happens. So we go back. So now when you select STS3C, again, HS1 and HS2, you get a high speed. So now, if you notice, there's only 16 mappings available. Well, that's because an STS3C is 3 consecutive STS1s together. So 16 times 3 is 48. So that's why there's only 16 available STS3Cs. Now, if you, for some reason, needed, 600 meg for an STS12C, now if you went to the mappings for this, you can see there's only 4, STS12Cs available. It's because 4 times 12 is 28. I've never had a customer need an STS 600 meg circuit on this. It could come, but it's there if we ever need it. Again, it has a 12C or 3C has to be consecutive. You can't have them spaced out in 1 here, 1 there. So kind of a special circumstance. 3C is a little bit more common. So let's go to the 3C. Let's go to the provisioning. Let's go to the high speed. So 1, 2, and 3 is the CFA. So that's going to indicate, that belongs to the first STS3C. So, we're going to go here. We're going to select the first mid-speed card. Basically, there is no rule of what mid-speed card you have to provision to. I've just, started with MS1, and once the backplane gets full in MS1, I've always gone down to MS3. And then, I think the limit is 24 STSs per mid-speed card, I believe, something like that. I have to look up the exact number. But there's a certain amount of STSs you can map to the actual mid-speed, and then once you hit the limit, it'll say destination card's backplane is full, and that's how you know that you have to use the next mid-speed card. So we're going to use VCGs 1 through 20. We're going to use the first one. We're going to do a new map, and we're going to create always a two-way protected map. We never want a one-way map. And we're going to do valid range of 1. So there we go. So there's our actual mapping. Basically, this maps an STS to a VCG. A VCG is not a logical container that holds the STS off the OC48. With that VCG, you know, we do other things, which I'm about to go over. So now we go back, and now we're going to go to our mid-speed module, our Ethernet provisioning. So we're going to go into the MS1, and then we're going to do the provisioning. Provisioning. I haven't done this in a while, and in a bit, so I'm kind of walking through it, kind of refreshing my memory. So if you look at the VCG provisioning, you see it's out of service fault right now. Why is that? That could be because, maybe it is not an STS3C. So on an STS1 environment, if you're provisioning STS1s, the single member VCAT has to always match. So if Verizon has single member VCAT enabled, we have to have it enabled. If they're disabled, we have to be disabled. In an STS3C environment, there is no such thing as having a single member VCAT enabled. It's always disabled on an STS3C environment. Well, we can go back to that. Let's actually do the flow provisioning. Packet handling, flow provisioning, select the list. So obviously, your flow number should always match the VCG. So let's go over some options in here and what we have to provision. So this is where basically you provision your VLAN information. So right now you can see it's out of service. Its enabled state is disabled, but when we're ready, we can enable it. So if you look here, you see your flow input. Your flow input should always be the actual module that, the actual physical Ethernet module that it maps back to. And, I actually label these. You'd actually have to go to the actual, it tells you how much bandwidth is available on the port. So if for some reason you see this bandwidth, there's no bandwidth available, you got to let me know so I can light up the second gigabit port. That's really never happened, but just for the future. Exceed the backplane's bandwidth before you actually exceed the bandwidth on the actual physical port, put it that way. So the flow input should always be a physical Ethernet port that drops down to the to the actual aggregation switch or the smart edge or what have you. The flow uplink is the VCG group that you have mapped your STS to. So I can see Dallin and Downey have already worked on doing this. You see how it gives you, if you look at that when I go back there, VCG. It tells you how much bandwidth is available on the VCG. Because an STS3C was provisioned, it tells you that there's 140 meg available across that STS3C. That's the actual real bandwidth available for the customer. So if they actually needed a 150 meg circuit and you're only provisioning an STS3C, that would not get exactly 150 meg. That'd probably get 140 meg because of that sign-on overhead. We'd have to provision 4 STSs really just get that provision bandwidth that they wanted. So over here, the flow name, guys, should always be the circuit ID. So, the VCG name and the flow name should really, should be the circuit ID only. It's the same thing concept when I provision stuff on the ONS, I always ask for the circuit ID. Since it's a MUX of some sort, we only want to label this with the circuit ID. It just makes it easier to track circuits, when provisioning comes, hey, they're looking for a disconnected customer, we can go into the Opti and we can say, hey, look, it's this circuit ID to this, to this STS, and then we can say it's a little bit easier to track that way. So it should only be the circuit ID in the name. So your flow you have your flow input, you have your flow uplink, your classification is the VLAN that you're passed. That's the inner tag that are referred to in the Q and Q. So if the first 2 or 3 OC48s, a lot of them terminate to the little phrase smart edge. On some of them, there is no switch in the way, so they terminate the edge. And they're on regular, 802.12 and 802.12 interfaces. You just have one single tag, and that's what's passed through here. But, with the queuing 2 up to the Manhattan Bur router, this is the inner tag. So, you guys chose 100, and it's always transparent. In the future, if AdTran comes up with a way where we can, have the AdTran strip off the tag where we don't have to, tag the CPEs, that's always but until then, you always have to tag the CPE with this VLAN that you choose here. And again, this is the inner tag on the Manhattan Bur router. Your up CIR and down CIR, these are multiples of 6432. It's in my document. But I have the actual values in my document of what you should use. So because this is an 3 STSs, we can do 100 meg. You can do a little bit over provision a little bit because we have 140 meg available to play with. And when the customer does an actual speed test, they'll should get close to 100 meg now because the committed information rate on the actual Opti is supporting that. So if we only did 2 STSs, we could only put like 92 meg in here. So this all looks okay. So let's make the flow enabled and see what happens. This updates on live. It takes a few seconds. So if you could see, this went to in-service active. Oh, and anytime you provision the commit information rate and has an exclamation mark, that means it's telling you there's not enough available bandwidth on whatever input or your flow input or flow uplink is that you have a provision to. So that usually an indication that 1, you don't have the STS provision to the VCG group, or 2, you have the provision to the wrong Ethernet port. So just take that into note if you ever see an exclamation mark next to one of these values.
Can you go back a second?
Oh, yes.
So the second column, options 14, 15, 20, 21, and everything else on the list, leave those as the defaults?
This one here?
Yeah.
Yeah, so the only thing that changes is the committed information rate, 17 and 18.
So the other values, you're not really acting upon anything.
No.
14 and 15 is just...
No, we don't rely on this to do any QS or random early detection, because it's fixed time flex. There's no other customers using that, those STSs besides that one, and the core routers doing any other QS.
Okay.
I'll show you the PowerPoint, but I lay out some values for them. Like for 10 meg, you can actually get nearly up to that 10 meg on it. Even though you're losing 40 meg overhead, you can hit that 10 meg. I have something for 50 meg. You're losing, unfortunately, about 5 or 4 meg on the overhead, and then there's one for the 100 meg circuit.
And in the flow provisioning, if somebody accidentally makes an oops and puts a VLAN ID that's used in another flow, what happens?
If you use it may actually warn you. It won't let you do it because it'll say it's an overlapping VLAN. I've never had that issue, but okay. I'm sure it'll warn you saying that it's been used by another flow.
Okay.
So actually, I wonder if I can. Let me show you an example of that little exclamation mark that'll come up. Since this customer is not in service, and we can play with it right now. So let's do number 2, where it's a second Ethernet port, and so let's do. We want to use the. It's actually not going to warn me now because it's already there, but we can modify it. So say we do 45. Let's do 10 meg. It still didn't come up. I'm surprised. Maybe it only happens when you do the VCG. If the VCG didn't have any STSs to it, let me put that back. See, it's saying effective serial port is oversubscribed because it's basically telling you it doesn't have enough available bandwidth because that port is not lit up right now. Let's change that back. Now it's no longer oversubscribed. Let's put that into enable. Wait for that to go in service, a few seconds. Once the VCG and the actual, so the VCG is going to, once when the VCG goes in service, you're basically matching end to end with Verizon. So let's go back to that VCG provisioning. See, it's still out of service for some reason. So the only thing I can think of is maybe I just provision as 3 STSs. So let's do this. To provisioning 8 for mapping. STS 3C mapping. 3C mapping with high speed. So let's go to here. Let's remove this. Delete the map. Let's provision as 3 STSs and see what happens. Put it back the way it was. 3. So if you want to provision 3 individual STSs, you go here, mid-speed again, the VCG, 1. And then basically you have to do a new map. It's always 2-way. You can do 3 consecutive, but if you want to do 2 individual, you would manually select each STS and then do new map under the mid-speed on the under the VCG. Just for showing you guys. So now, basically, I put it back the way it was when we first started this training. It's 3 individual STSs. And you can tell it's mapped to VCG1 on card mid-speed 1. Let's back out. Let's go to the flow provisioning. The mid-speed 1. Provisioning. VCG provisioning 1. And it's still out of service fault. So the only thing I can think of, let's disable this. If you do any changes on the VCG, you have to disable it first. So let's enable single member VCAT and see what happens. And now let's re-enable this. 5 to enable. It's not going in service, so there's still an issue, provisioning issue between us and Verizon. So for now, what I'm going to do is going to leave it the way it was before. So Dal, you got to go back to provisioning and ask IC and ask what Verizon has this configured as an STS 3C. Is it configured as do they have single member VCAT enabled? Is it 3 individual STSs, that type of thing. So let's put that back to.
I'm sorry. So on the
Okay.
For the layer 3 part of this order, where does this DPHBY? Where does this one live? I know DPLL1 lives on LaGuardia. Where's the other one live? I couldn't find that on the carrier hubs document. That's what we ran into last night.
No problem. So let me just wrap up this Opti provisioning. So that's the VCG is out of service, but if you go back to the actual flow provisioning, as long as you have all your your values proper here, this is always going to yield in service. Whether or not you have sync with across the SONET network or not with Verizon, this will always be, if all these values are proper and map what they should be, this will always be in service. So there's an issue with the SONET provisioning with Verizon. So it's either got to be an STS 3C, it's 3 individual STSs, maybe they have, I don't know, there's something wrong with it, but IC has to go back to Verizon and verify how this is configured on their network. If this was only 2 STSs, it'd be a little bit easier because we would know for sure that it could only be 2 STS1s, but since it's 3 STSs, they could have it as an STS 3C. I don't know. I mean, we tried it and it didn't work, so maybe there's a goof up on Verizon's side. So does everyone kind of understand that part, the Opti provisioning? Crickets? Yes, no?
Yes, I understand the Opti provisioning side of things,
Okay.
yes.
Okay. For the Fidelity guys, I know this is brand new to you guys, and there is documentation out there on basically what I just went over. So let's do the quick part, which is the layer 3 provisioning on the core router. So to answer your question, George, this is in reference to the email that I had sent out about this. So I reference, this new OC48 here. I tell what ports it connects on the AG switch, just for your reference. But then I tell you where the Q&Q interface lives on the LaGuardia Burr router. So let me get into that. And 10 million secure CRT windows open. So if you look here, bunch of interfaces. Let's make this a little bit easier on ourselves. Show it. Description include TE 0201. You didn't like that, did you? Oh, because I had this wrong. So this is the 10 gig interface that that uplinks to those AG switches in Little Ferry. It goes over a dark fiber between Manhattan and Little Ferry. But so if you look, 2000 is the one for that DPSL1 that you guys have been working on, for the past how many months. 2001 was a separate. Do I have that? 2000. That's 2000, right?
Yeah, that's 2000, yes.
Okay, yeah, well, my eyes are just calling there for a second. Okay, so 2001 is a separate one that I let up for our backup circuit that replaced our DS3 in Wayne, New Jersey. So that actually, that's off of a separate port on the AG switch. So you can provision other stuff to that if you had to, but that was just a separate link I lit up. Now, if you look at my email, so anything with the 2002 should be for anything on MS1, and anything with the 2003 should be for MS3. Do you understand a little bit more now, George?
I do. Was it labeled like it is? Like the DPSL port is labeled, and we also had that on.
You actually really can't label it. I mean, I guess it's hard to label it because it's not a physical port. The entire port itself, goes to the physical AG switch in Little Ferry.
Oh,
the actual sub interface, you can't. It's just a numbering convention for the sub interface.
Okay, so both DPSL. Okay, that makes sense. I said no, that makes sense. Okay.
So because it's not like the number after the dot is it's kind of, it's not like you can have a parent and a sub like on a main interface and you have all the sub interfaces. So that's why I sent that email out. So like you see 2000, 2000, 2000, 2000, that's for anything for DPSL1. 2001 is for anything for the JD HVX on a separate port that I lit up. So basically for MS1, for this one, you'd have 2002, and then you have 2002, and then you would have 2002 100 for this Metro Optical customer. And then 2002 whatever, 2002 101, 102, 103 for the next customers, and so on and so forth. Then once that MS1 backplane gets full, then you would go on to 2003, 2003 100, 2003 101, and so on and so forth. And if you look at an example, let's look at any one of these. You can see the actual configuration.
And the outer tag in that is actually the CPE side sub interface, correct?
No. So the outer tag identifies what port it drops down to on the AG switch in Little Ferry. The inner tag. So this is the outer tag. The first number is the outer tag. The second number is the inner tag. The inner tag, the second number. What's that, John?
So if it was 2000, let's say 2002, 100, 100 would be the CPE side.
Correct.
Okay.
2002 would be the port that identifies it on the actual ag switch to the Opti. So
Gotcha.
this is what that's a layer 2. Well, this is a pseudo wire customer. You can tell because it's labeled as an L2 transport. You should be able to identify that right off the bat. Any layer 2 pseudo wires are identified as an L2 transport interface.
Hey, thanks, Curtis. Sorry. Hey, I have to drop off, but thanks.
Okay. Yep. So, this is just, this is how a layer 3 Q&Q interface looks on an ASR, basically, for this, for this type of thing. It's the same. Anytime you do Q&Q on the ASR, it looks the same. As, the numbering convention on the actual sub interface, basically. So, that's pretty much it.
That CPE side, on that example you just displayed, the CPE side would be .1Q24.
Yes, the actual WAN interface would be tagged with, whatever WAN facing Ethernet port would have, whether it's gigabit or fast Ethernet, 00 or
right.
gig 00 slash, 0/0 .24, and then encapsulation
Right.
.1Q24. There are some instances, with Metro Optical. Metro Optical likes to, they're a reseller, they're a wholesaler of us, and we also buy circuits from them, so it goes both ways for that specific company. In some cases, Metro Optical likes to provide their own CPEs. That's fine, but if we're selling them a circuit off of this type of hub, we have to be conscious of that, and we have to tell them, hey, you have to tag the WAN side of your CPE with so-and-so VLAN. Because basically, their CPE is acting as our CPE. They just don't want to use ours.
And that's just with Metro Optical, you're saying?
It's typically seen with Metro Optical, and another one customer is GTT.
Okay.
Those are two prominent customers, that they're wholesaler with us, and we also buy circuits from them. So we don't really give them a hard time. And the other one, I'm sorry, is you got GTT, you've got Metro Optical, and you also have Access Northeast, aka TierPoint now. You'll see that. You'll see whenever they place an order, TierPoint will always want to use their CPE on site, which is fine. They just have to take in that tag. So, any other questions?
Hey, Curtis, I had to drop off for a second. What information do I need to go back and get?
No problem. So basically, your Ethernet provisioning is fine. There's no problem there. It's in service. Your VCG is still out of service, so there is a SONET issue between us and Verizon. There's got to be a mismatch, or maybe Verizon's not provisioned properly. But since it's being that it's 3 consecutive STSs, we need to know if it's an STS 3C or if it's 3 individual STSs.
Okay. All right.
And whether, if it's 3 individual STSs, we need to know if, single member VCAT is enabled or disabled.
Okay.
And, because we've tried all 3 options, in this training, all 3 options didn't work. So, again, there could be some provisioning, maybe they're not fully provisioned on their network or something. So, there's some issues still going on. But we definitely need to know 100% what Verizon is configured for.
Right. Okay, not a problem.
Okay. No other questions? Going once, going twice. Okay. You still there, Jason?
Oh, I'm still here, Curtis. That's fine. We appreciate everything.
No problem.
Reach out to you if we have questions. Thank you very much.
No problem.
Yeah, thanks,
I just want to stop the training. Can I don't know.